So, hello everyone, and welcome to the session from Tech Hut on Docker and containerization. So, let's get into this. So, before Docker, in this section, we'll discuss what kind of technologies were being used before Docker. So, mainframe, we'll start with mainframe. So, you remember the big old mainframes which were being used to host the applications. So, when we say hosting an application, let's say we have a web application, so we have to host the application somewhere so that it is available to the public. So usually hosting works like, let's say you have a front end which is basically an HTML and JavaScript files, so those will be hosted on a file server, and that file server or HTTP server, it will be made available to public. And let's say you have a website name. So that name will be mapped to an IP address, and that IP address will be pointing towards a server where you are keeping those HTML and JavaScript files. So that is how the mapping works. And we have to host our application code and everything on a server in order to make it available to public. So initially mainframes were being used, and there's an option that people can use just their in-house PCs and servers and make their application public by opening up their network towards the public World Wide Web. Then the option came of using virtual machines. So virtual machines are something that that kind of shares your infrastructure into different compartments where different operating systems can be configured and they can keep on running. So yeah, so you can see here that infrastructure is here. Then there's hypervisor. Hypervisor is software which uses the underlying infrastructure and make it available for virtualization. So virtualization is really important factor here, which enables the products like virtual machine, Oracle virtual machine, VirtualBox, those kind of products to share the infrastructure between different applications. And in this case, those applications are nothing but virtual machines running. Okay, let's move on. So compact Linuxes. So what happened was people started working on creating a compact Linux. Basically, how by removing unnecessary binaries, some hardware-related drivers which are not actually required for a compact Linux, and removing UI and UI-related code. And we came up with a Linux which can be as small as a 5 MB. So you can check Alpine Linux on Docker Hub. It's just a 5 MB Linux, and it only includes the um, bare minimum code to run a basic Linux operating system. Let's move on. So what is Docker? So definition wise, Docker is a platform that uses OS level virtualization. Okay, let's pause here. Virtualization, the virtualization which I mentioned for virtual machines. So Docker uses virtualization, but on operating system level to run isolated software packages. So isolated is another keyword. So the containers or packages running inside Docker are isolated from each other and the operating system. There's a key factor here with their own operating environment. So every package which is running inside Docker can be can be made to do a specific task. One Docker container can be just for a node server, one Docker container can be for a front end, one Docker container can be for database, one for caching. So everyone will have their own configuration and their own operating environment. So Docker helps us facilitate this whole scenario with their Docker daemon, which we install on the systems. Let's move on. So Docker image, what is a Docker image? So we'll just go through some terminologies which are used in Docker, so you'll get to know more about it. So Docker image. So Docker container image is a lightweight standalone executable package. So lightweight, as I said, Alpine just 5 MB, so it can be lightweight standalone executable package. So as it is isolated, it itself can take care of all the environments, all the required binaries, and it can run. So it doesn't require anything from outside. Standalone package. of software that includes everything needed to run an application. So every time we create a Docker image or a Docker container, the sole purpose of doing that is to run some application, some binary inside that, or else it's just no use of doing it. So that's why Docker image should contain everything required for that application to run. So that includes code, runtime, system tools, system libraries, settings, all those things. Whatever is required for a particular application to run inside Docker, all those things will be available in the image. Let's move on. Docker container. So let's go by definition and I'll explain. Docker container is a runtime. It's a runtime isolated lightweight environment. So Docker image was just an executable package, but Docker container is a runtime isolated lightweight environment. So you can think of an image as a class and container as an object. So image is just a blueprint and container is actual runtime environment. So created using corresponding Docker image. So that checks out every container has a corresponding Docker image to run an application with all its dependencies, because those dependencies will be present in Docker image itself. So yeah, you can see the difference between how the virtual image, virtual machines and containers work. So we have infrastructure in both side have operating system. Here we have hypervisor and here we have container engine. But with virtual machines, every VM will have its own operating system, its own binaries and everything. And on top of that, the apps will live. But in case of containers, it will only have the binaries and files in the operating system required to run that particular application. So it will be lightweight. So yeah, also when you run a Docker image, you get a Docker container. Small thing. So Docker volumes. So when you're running a Docker, and let's say when you're running a node backend on Docker, and basically that backend is receiving files from some front end, and that backend is supposed to save it. So in such a cases, whenever you stop a container, or in such a cases, when you stop the process, when you stop the backend server and you restart it, the expectation should is that the files which were uploaded in the previous run, those files should be available. But in case of a generic Docker container, it's not possible, because every time we run a container, it starts fresh and there is no data, there is no unnecessary things which are there. Uh, when you run it first time and you upload some files, those files will be present in the Docker container as long as the container is running. But the moment you stop the container, those files will be lost. So to solve this problem and to have a persistent file storage, Docker has Docker volumes. So what you can do is, you can in Docker volumes, you actually attach a folder in your host system to a folder inside Docker. And basically we have to mount the host folder on the Docker folder, and the Docker process can directly access the folder. So I can just explain it easily. So this is Docker container, and Docker container has, let's say, this folder inside it, slash data. And you created one folder in your operating system called data, or anything else you want. But you can mount this folder onto this folder, so that every time the process inside Docker saves any file in the data folder in that Docker container, that will be directly sent to the folder which is inside your host system. So it's like uh, attaching or if you have used via a virtual machine, Oracle VirtualBox, so there also they had facilities of mounting folders. So that mounting capability is implemented in the form of Docker volumes, but made pretty easy to manage it as compared to the VirtualBox environment. So why Docker? So the first and most important thing it solves the problem of it works on my system. So developers develop some application. He's installing n number of dependencies. The application is using different binaries. It has a database. So whenever you're developing an application, there are a lot of dependencies on the development machine itself. And now let's say you have pushed the code and someone else is pulling it and trying to run it in their system. But if they forget to install even a single dependency, they forget to run the npm install, or some version of particular package is mismatching. You use node 14 but they're using node 12. So there are a lot of problems when it comes to just like picking up a code and putting it in someone else's system and trying to run it. But Docker solved this problem. Why? The same thing as Docker. In Docker, whenever you create an image for a particular application, that image contains all the dependencies, all the versions, everything needed to run that particular application. The whole and sole intention of creating a Docker image is to be able to run that application. So that's why it solves the it works on my system problem. Then it is lightweight and isolated. Yes, we have mentioned that multiple times. Interoperable. So one Docker image can run on Windows, the same image can run on Linux, the same image can run on Mac. So it works on all the operating system. That is one of the power which gives Docker, because when you're working in a team where there are like different developers, different testers, business analysts, everyone is using different operating system on their system. Like you cannot expect a business person to use Linux because they don't have much use of it. So this basically solves that problem because one Docker image will work everywhere. It works great with CI/CD. So CI/CD is continuous integration and continuous development. So continuous integration means wherever you are writing a new code and you're pushing that code, automatically that code will, whenever the code reaches the GitHub or any DevOps software you're using to manage your code, automatically it will create a Docker image from your code. It will test it, and it can deploy it also at the same time. So that is what means CI/CD. And Docker is really good with good for CI/CD because the CI/CD just need to know what is the name of the Docker container, and directly using that name, they can the CI/CD is able to deploy it on cloud or any other VM which you're hosting anywhere the way you want. Same thing, CI/CD comes under DevOps only. So DevOps are really easy with Docker. And Docker is helpful while development as well. So okay, so let's say one person is handling three different projects, and for one project he has to use Node 14. For one project he is using Node 12. So node versions are different. Let's say for one project he has to use MongoDB, but other one expect him to use SQL. Some other one they're expecting him to use PostgreSQL. So this person has to install all these software in his system just in order to run the projects, and he's not using them every time. He is just using MongoDB and these other softwares when he wants to run his code. But if that developer uses Docker containers instead of installing everything on his system and using it, starting a service, stopping that service is easy. Like just few clicks or just two commands, and you can just run and stop any container you want. So even in development it helps, and I'll show you how. Okay, it's time for demo. Um, so you guys were saying that.
Sir, any installation process is required or what?
Yeah, so you have to install Docker from Docker Hub. That's why Docker. It's easy enough for Windows, so just like Docker for Windows. There are simple guide available. Just download the exe file, install it. Even for a Mac, it's just a DMG file, just install it and it will run. And like most of the instruction, even for Ubuntu, just single command or few commands, and it will just work on the system. So installation is not that difficult. And Docker is all about the commands. Once you install it, you'll have Docker here, Docker running. Um, They have a new dashboard which they come up with, which shows which images are containers are running, how many images do you have, all the images. Then there's something called Docker Hub. So Docker Hub is like a catalog for all the images available there. So you can see PostgreSQL, BusyBox, Ubuntu, Alpine, Redis, Node.js. All these images are available there. Basically, you can just pull anything you want and run it in your system. No issues. It's that easy. So okay. So while we're on the topic, um, Redis is an open source key value store. So usually people use Redis for caching. So if you want to run Redis, you can just copy this Docker pull Redis and run it here. And it will, you see, it said it is pulling some layers, right? So there are different layers with these unique IDs assigned to them. So when I say layer, they are file system layers. Like there will be a kernel, there will be like some, let's say you have to install Redis, then some configuration about Redis. All those things are represented in layers and you get it. So, okay, now I got the image. Using Docker images command, we can see all the images installed on the system. This is fine, right? Size wise. So you can see the repository. So it's Redis. What is the size of it? Then ID and other details which are required. So once we have the Redis image, we can just run it Docker run command -it. So -it enables interactive model. So we can just enter some commands in the container after it is running. -rm removes the container once we stop it. Like it's like a temporary container thing. So we just want to run it after this command is executed, and once we do Control C and we'll just stop the container. It will be removed altogether from the system. Redis. Now Redis works on port 6379. 6379 colon 6379. So this statement -p 6379 colon 6379. So -p is for port, and what it does is basically it attaches the 6379 port of this image to the 6379 port of the host system. So as I said, every Docker image has everything, like all the things it is required. So as our system has uh, 0 to 2553 something big number of ports, the same way every Docker container also has those many ports. And when we run a Docker image, like if I run it without this, nothing, yeah, okay, it started Redis and everything. And let's say, so I have Redis CLI installed on my system also. So if I do Redis dash CLI, it is say not connected because it is not able to connect to a Redis on this port, because the port of this Docker container, which is running Redis, is not yet open. Because of that, the local system is not able to access that port. So now if we add these statement -p 6379 colon 6379, enter. And now if I tried it, I'm connected now. I can just, add some command like set name, Utkarsh, get name, because it will work. If I connect it again, it is still there. And the moment I control C, it will stop, it won't work. So a basic example to how to run an image. So Redis is usually used for like in development when you want to implement caching on your backend side, or if you want to just just save some data and quickly access it at that time, we use Redis. But that doesn't mean I have to install Redis on my system. I can just do a Docker pull. I can have the image, and whenever I want it, I can spin it up. I can then spin it down. A simple example. So VS Code has a lot of extensions for Docker. So just a second. Hmm, It is still running it. Let's say Docker PS. So Docker PS is used to list down the Docker containers which are running. I think there is this one container, it has been running. And whenever you create a Docker container without any name, Docker automatically attaches a name. So they have a list of names and they just append them using underscore and some random names generated. Actually pretty cool. So Docker, I'm not sure, remove. Mm, You can copy the hmm, just the VS Code has the extension, so you can just remove it from here. Okay. So that was about Docker images, Docker containers, how to run a Docker image, how to list down Docker images. Um, okay, now let's try. So, okay, I think I'll show you the website. So this is the website which we have created for Tech Hut. And I have the code of this website on my system. And I'll show you how to Dockerize it and run it in your local. So this is the code DSCMS. It has this index file, which is running a node backend. And of course, it has this package or JSON file and all the dependencies. So these dependencies and everything, these are installed on my system already. In node modules, they are present. But when I create a Docker image, it's a complete new environment, right? So we have to do the installations, like we have to tell the Docker container how to create an image. So we are actually creating a new image for this application, the SCMS. So when you want to do it, just create a Docker file without an extension, D capital F small in your system. And this is the syntax, which is you like it's kind of a set of instructions which Docker daemon follows to create an image. So from says like we need a starting point, right? We are creating a new image, but we are not starting from zero. We need some starting point from which uh, we'll do some processing on that image. So we take node image because we are running a node server itself. So we start from node version 14. Then these are label where you can just add the authors. Now, okay, let's first run this node image and I'll show you what do we have inside. Hmm, hmm, That's interesting. So node will be an empty image when we begin with, and we have to install everything. Like we have to do first, what we do is we copy the package.json file, which is here. this package.json file, we copy it inside the node image here in www/package.json file. Once we have it there, we'll just do a cd, we'll change directory in www, and then we'll run npm install. So we have to do npm installation. And if you see this docker ignore file here, so in that you'll find there is node modules. So while creating container, it will ignore the node modules folder, because this node modules is according to your laptop, your operating system, the node modules are installed here. But the underlying operating system of Docker can be different, of your image can be different than your local system. So we don't take these files with us while we're creating the container. We'll run a manual npm install inside node 14. So we'll have our own node modules folder in the image. Then we'll copy dot, like we'll copy everything in this folder except the folders mentioned in Docker ignore in www. Then we'll set that the working directory is www. We'll assign the port, that which particular port we want to open. I think the statement came twice. Anyway, it won't matter. And we'll expose a particular port, like this is the port where the application is running in this particular Docker image. So using expose, we tell the outside world that this is the port, and then we'll start the application using npm start. So in order to create a Docker image using Docker file, you run /docker build -t. So -t is used to give a name or a tag to your image. So I'll say dscms and dot. So dot means inside dscms folder. Inside this folder, it will, when we say this, it will find the Docker file and it will execute every statement one by one. And say this is transferring all the context first from Docker 14. So it is pulling the image and it copied the file back into JSON. It did the npm install. Then all the steps one by one are done, and we got this image, dscms. Okay, so Docker ps. You see dscms latest 2.12 GB. Now, if you want to run this image, we'll do docker run -it-rm and the name of image port -p. So 9090 was the port, and name of image dscms. You see it is running index.js, the npm run start command, npm start. So this command, this entry point, this executes when you start the run the image. At that time, it will run this command. Okay, so let's see if it's working or not. Yeah, see, the requests are going inside and it's working.